Let's see what happens with this integral if we use the u substitution 4x squared plus 3. Taking a derivative of both sides would give us du equals 8x dx. Now we have a couple of options as to what to do here. You'll notice that our u is in the denominator here, so we're going to have something over u. But I see that we have a 2x dx here in the numerator, and we have an 8x dx that we'd like to substitute into this problem. One way to go about this would be to notice that if we divide both sides of this equation by 4, we get 2x dx on the right-hand side, and that's exactly what we have here in our integral. Then, making the substitution is just going to give us a 1/4 du as all of the circled stuff up here, and this 4x squared plus 3 in the denominator is just a u. We could then rewrite that integral as 1/4 du over u, and you'll recall from our previous studies that the integral of 1 over x dx is just the natural log of x. So our answer is going to be 1/4 times the natural log of the absolute value of u plus c. We can then substitute back in what u is, and we get 1/4 natural log of 4x squared plus 3. Add a constant to that, and that answer looks great. Now I mentioned up at this step that there were a couple of different ways to proceed, so I'm going to show you the other way really fast. What we could have done in this step is solved for dx. That would have given us du over 8x equals dx. And then I'll rewrite our integral, and if we replace this 4x squared plus 3 with our u, and we replace our dx with our du over 8x, you'll see what happens is we get some cancellations. We get the x in the numerator and the denominator cancel, and then this 2 divided by 8 can turn into a 1/4. We can pull that outside, and we're left with the same integral du over u, which gives us the same result. Generally speaking, I tend not to use this method because of this step right here. I don't like the fact that there are still x's in our integral here, mixed with the u's. We have the old variable x mixed with the new variable u, and that has a tendency to bother me a little bit. Now, knowing how to do this can sometimes be helpful, but when I can, when switching variables in an integral, I like to completely switch all of my variables at once. So I go from an integral that has all x's in it to an integral that has all u's in it, without any intermediate steps. Anyway, just my opinion. I hope this video helped, and let's get some more practice in the next one.